Spark. I'll give you overview about Spark. Again, we will not be getting into too many details today, but I will give a very good overview. After walking through all the services which we have on the cluster, then we will actually get into Hive and then Spark very much in detail. Okay. So that being said, just give me a moment. Let me add this video to the playlist. So to begin with, as part of the setting up the environment, I have asked you to set up IntelliJ, Scala, and Spark on Ubuntu subsystem for Linux. Okay. I hope everyone have done that. And I will be demonstrating primarily from Ubuntu for subsystem, using Ubuntu, which is installed or set up with Windows subsystem for Linux. Okay. If you do not have that, make sure you have that at least by the time we start on this Spark. Okay. So here I'm starting my Windows virtual machine. Can you say session have started on the WhatsApp? Because only 18 people have joined so far. And also mention that we are talking about Spark overview and Sqoop today. So let me close few of these unnecessary things which I have on my VM. Pig I will be covering tomorrow. So we'll be walking you through all the services we have. Pig is not that important, but I will give a brief overview. Pig is being decommissioned or re-engineered with Spark and all, because Spark gives you a lot more flexibility with programming language like Scala, Python, etc. than Pig. So don't worry too much about Pig, but I will give a brief overview tomorrow. Okay. So that being said, now let me launch the Ubuntu subsystem. Okay, I think this is not the one. Let me close this. Yeah, this is the one. So after setting up Spark, so Spark works with multiple programming languages. It works with Scala, Python, as well as Java. But it is more popular with either Scala or Python than Java. Okay, that's why we are covering only Scala and Python as programming language than Java as part of this course. That being said, once you set up the environment and also once you have the environment variables set up properly as part of dot profile or dot bash profile, okay, like this. So for Shiva and those who are using Mac, you don't need to set up Ubuntu subsystem for Linux and all. As long as you set up the environment properly, you should be able to launch Spark Shell directly using terminal. Okay. Only thing is, I am demonstrating on Ubuntu. It can easily map to Mac, and you can start using it on Mac. There won't be any differences between Mac and Linux. Okay, except for user experience. That being said, now let me see. So at this time, Spark shell is not added uh, uh, to the environment variables. Hence, I have to first do that more before doing anything else on this system. So here you can access your C drive, D drive, etc. on Ubuntu subsystem for Linux of your Windows by using /mnt. Okay, and then you will see C. And then, okay, I think I thought I have set up. Let me quickly set up. Let me see. Find. So let me set up quickly. I have given instructions also as part of the blog which I have shared earlier. So here I am launching Chrome. Or I think I already have in the downloads. Let me check in the downloads first. Something is wrong in this. Okay, there's something wrong in this. Let me see. Google.com. Let me do once more. Parallels. Let me try one more time. If it does not work, then I will show on the Mac itself directly. Something is wrong. I need to troubleshoot and fix this Ubuntu issue. Yeah. So let me show you on the Mac. You can use this the same way on the Ubuntu subsystem for Linux as long as the environment is set up. So make sure your dot profile or dot bash profile is set up properly and have the details with respect to your Spark Spark home, and also you need to make sure that the bin of the Spark home is appended to path. Then only you should be able to run from anywhere. If you don't have environment variable set up properly, you will not be able to run commands from anywhere. You have to give fully qualified path. Okay. So in this case, I can say Spark. So if you are using Ubuntu or Mac or even Cygwin, if the environment variables are set up properly, if your commands are available from anywhere, once you type something and if you hit tab, one couple of times, you will see the list of commands available starting with the string. If you can't see this, that means there is something wrong with your environment. You have to fix that first. Okay. And as I have mentioned to you, Spark is supported using multiple programming languages. Means you can build Spark-based applications either by using Scala or Python or Java. Okay. So Scala and Python comes with REPL or command line interface, so that you can interactively uh, develop and test your code snippets. So to launch Spark in Scala, you have to use this command called spark-shell. If you want to launch it in Python context, you have to use command called PySpark. So Spark shell will launch your your Scala REPL with Spark binaries. PySpark will launch Python REPL with Spark binaries. So you should be able to use the APIs provided by the Spark. So if you recollect earlier, when we actually build Scala-based applications using MySQL, we have updated build.sbt, which have downloaded the external dependencies, and then only you are able to use the APIs. Okay. When you do Spark shell, it is automatically taken care for you. It will actually get all the Spark binaries for you, and you should be able to use Spark-based API as part of your code. Okay. So that being said, let me launch Spark shell here. So if you see, unlike Scala, it took some time to launch this session. Why? Instead of just launching with Scala-based APIs, it also registers Spark-based APIs or Spark-based binaries. And also it created something called Spark context and Spark session when this is launched. Okay. What is Spark context and what is Spark session? We will see when we actually get into the details with respect to Spark. For now, just remember that Spark context is a web service which will be running on an IP address with a port number. And those details you can get it from here. This is the IP address and this is the port number, and that is where Spark context will be running. As it is launching a web service for you, it is taking a bit more time when we say Spark shell compared to Scala. Okay. And also you can see Spark context is available as SC and Spark session is available as Spark. Okay. And to create this context, it can be created using multiple frameworks. One is Yarn, which we have seen day before yesterday. So if you have a cluster with Yarn and Spark integrated, you can launch your Spark context with Yarn mode, which means you will get a distributed or multiple nodes to process your data. Don't worry too much if you do not understand what I was talking. You will understand at a later point in time. For now, just understand that Spark context can be opened in multiple using multiple frameworks, and one is Yarn. By default, if Yarn is not integrated, it will be launching using something called local mode, which means it will be using the resources locally. Okay. Right now, I launched Spark shell without any control argument to change the behavior, and the default behavior is to launch the web service only locally, to launch the Spark context locally. Okay. So here, let me open PowerPoint. So in this case, when I launch, let's say this is my laptop. Okay, it has CPU, memory, and storage, right? So when I say Spark shell, it creates something called JVM, Java Virtual Machine. Okay, and that JVM will need some resources. So which means it creates a process and that process takes some resources. By default, it is 1 GB RAM and 1 CPU. I have 8 CPU laptop. This is not a quad core, so 4 CPU laptop. So the Spark context will take 1 CPU and 1 GB RAM, and it will create a process here. Okay, so this is JVM, which is created when we say Spark shell. And when it is the local mode, uh, there will be either one JVM like this on the PC where we have ran Spark shell. We can also specify multiple JVMs also if your PC or server is powerful. Okay, but by default it will only take one, and hence there will be only one JVM like this, which will be added to the already existing process. Okay, and now whatever code you write will be executed in this JVM. So to execute your code, there has to be either a JVM or a web server or application server, whatever it is. If it is web application, it will have web servers. If it is non-web applications, typically we need JVM if it is Java-based stuff. Okay, as Spark is developed using Scala, and Scala is a JVM-based programming language. Typically, irrespective of the programming language you use to invoke the APIs and process the data, it internally uses JVM only to execute your Spark code. Okay, even when you develop in Python, internally it will execute within the JVMs only, because you are invoking Spark APIs from Python, and Spark is developed using Scala, which is a JVM-based programming language, and hence a JVM is required. So, irrespective of the programming language you use to build Spark-based applications using Spark APIs, it will be executed in JVM only. Okay. So this is what is happening when we say Spark shell. Now, again, this is only for your convenience to start developing the code. Okay, to explore your code. The formal way of writing the code is you need to use IntelliJ or PyCharm, depending upon the programming language you are trying to use. Okay, so I will also demonstrate how you develop using IntelliJ today. But first, let us see how we can actually explore the code using REPL. So we have data, our retail DB data. First, let us see the path where we have the data. So I have on my local PC, I have set up data under this location: users, IT Varsity, research, data, and then I have two directories. One is retail_db, and the other one is retail DB JSON. So retail DB have comma separated data. Retail DB JSON have JSON data in JSON format. Okay. So now let's say I want to process the data the way we have done with Scala. Okay. So when it comes to Scala, can you guys tell how did we read the data from order items using Scala? So we have data in this location. There is a file in this location, and we read this data in Scala. How did we do that? You did all the exercises, right? So tell me, how did we read the data from this location using Scala? How did we read? Did you read the data from files? How did you read? Look at your code and tell me if you already did the exercise. Okay. So you have used the API by passing the path, and then you load the data, right? Yeah. From Scala.io package, there is a class called source, and there are APIs like from file, which will load your data in file into a string in memory, and then we have used API getlines to use new line character as delimiter and convert that in-memory string into a collection. Okay. So when it comes to Spark, to read the data, already there are APIs. In Scala, what is the package? It is scala.io, and there is a class called source. That is the one which have the APIs to read the files. Similarly, in Spark, the Spark context object. So in this case, SP is of type Spark context. Okay, and SP have several APIs, and one of the API means several APIs to read the data from files itself. And if you want to read data from text files, okay, when we say text files, what do you mean, what do you mean by that? Okay, what is that? Okay, so is this not a text file? So is this not text file? Is that not text file? Is it a text file or not? What is that? And there is no extension. Then how are you saying it is text? Yeah, the file should have alphanumeric characters, not the file name, but the contents of the file should have only alphanumeric characters. Okay, so even .doc will have alphanumeric characters when you open it, but internally it will not be stored as alphanumeric characters. So it's not only the content should be alphanumeric, but also the way it stores internally also should be using alphanumeric. When you say doc or PDF, they actually store in binary format. Extension is primarily for the information purposes. Extension, I can rename a file from .mp4 to txt. That doesn't make mp4 file a txt file, right? So extensions is only for informative purposes. They are not the actual. They don't control the actual file format. Okay. So in this case, part-50 is a file which contains only alphanumeric characters, and also it's saved directly using those alphanumeric characters without converting into some binary format. Why Microsoft stores doc files in binary format, or Adobe stores um, documents in PDF format, or your data in PDF format? What is the reason? Why Microsoft? What is that? No. Can anyone guess why? Even though, so this is mainly for entry-level professionals, all seniors should be aware of it. Even though most of the times doc and PDF files contains alphanumeric characters, why Microsoft or Adobe stores that information in binary format? Tell me. What is that? Yeah, it one of the answers, but there is more accurate answer than that. So if you actually, what is that? No, accurate search you can do it from the text files also, and it is more efficient to search from text files than from the doc, Microsoft Word doc or Adobe PDF. So there you are trying to store the documents. Document means not only alphanumeric characters. You have to save pictures, and it also gives features to format your data. You can bold your data, you can underline your data, you can strike through your data. So there are so many features they give to you. To support all those things, if you just save your data in text file format, it is not possible. That's why they save in their own proprietary format. Okay, that is one reason, and another reason is it is revenue generating product for them. They don't want to just open up for everyone and store in a standard format. Okay, so these two are the primary reasons. Now they have changed that a bit because of the open source revolution and all those things. They are trying to save, even though you save the doc file internally, it will be means if you want, you can actually store into XML format, and you can open with other compatible tools such as my Google Docs, etc. If it is Microsoft Word doc, it can be opened with Google Doc also, because now they are saving in industry standard format, not just their own proprietary format. Okay, so there's much bigger logic behind why they are saving in the binary format internally. Okay, so it's not just for search or security or whatever it is. Even though you typically see alphanumeric characters in the doc or PDF, but you also have images and formatted data, etc. That being said, now this file, to read the text files, there is a API called text file, and SC also have other a few more APIs to read files of different file formats also, such as sequence file, new API Hadoop file, or Hadoop file and new API Hadoop file, and Hadoop RDD and new API Hadoop RDD. I will explain why we have these 4 APIs at a later point in time. But for now, to read text data, we use text file. To read binary data with some standard. It's not just any binary data, but binary data in some predefined standard. We can use sequence file. So these are the 2 APIs we can use to read the data. And you have to use the appropriate API depending upon the type of data you are trying to read. In this case, we are trying to read alphanumeric characters based text data, and hence we can use text file. Okay, if I want to read a Word doc or PDF, this will not work. Text file or sequence file will not work. If Microsoft is interested to actually make their product compatible with technologies like Spark, they will provide the plugin, and as part of the plugin, they will provide you the API, and then only you should be able to read the Microsoft Word doc or PDF doc as part of your programs, whether it is Scala programs or Python programs or using Spark APIs, it doesn't matter. The specific vendor or some third-party company has to provide you the plugins. Then only you will be able to read data from Word docs or PDF files. Okay. So that being said, I am reading data from order items using sc.text file. And what should I do now? I first need to understand the syntax. How to understand the syntax in Scala? Just hit a tab twice and you will see the syntax. And the text file take 2 arguments, path and min partitions. So you can ignore min partitions for now. So the first argument has to be path. And what is the path? So in this case, the path is nothing but this one. And with Scala.io.source using from file, we have to give fully qualified path for the file. So what if the directory have multiple files? You have to develop the logic of getting list of files from that location, and you have to read one file at a time if you want to use Scala.io package to read the data. With sc.text file, you can actually pass the directory itself like this. And if there are multiple files in that location, all the files will be read automatically for you. But if you have directories and files together, then you might run into some issues. As long as there are files only in that directory, and as long as those files are similar, you should be able to write code without any issues. But if you have combination of directories and files, or if the files are not similar, then your code might not work and you might be running into different types of issues depending upon the situation. Okay, now that's it. What this sc.text file will do, it will actually get the data from the file and creates a collection for you. You don't need to use after from file, you don't need to use get lines again to convert your string into collection. This sc.text file itself will read the data from the file into a collection directly and hit enter. And what is the type of the collection? This is the, what is the type of collection? 7? No, you are not getting the logic properly. String is not a collection. What is the type of collection here? I have highlighted also. Yeah, that is correct. RDD is the type of collection. So this is the type of collection. Each element in the collection is of type string. If I create list like this, you can see it is of type list and each element is of type integer. So in this case, our order items is of type org.apache.spark.rdd.rdd. Okay, it's a fully qualified class name. Okay, so it is of type RDD and each element in that is of type string. So the difference between list and RDD is nothing but extension to list. What is the difference between list and RDD is the main question here. So for that, first you need to understand the difference between Scala and Spark. What is Scala? Functional programming language. Is Spark a programming language? What is my question? Is Spark a programming language? Yeah. So you should answer properly. That's what communication is. You don't need to be very good at English. First, you need to understand the question and you have to respond accordingly. Yeah, now you are correct. It is not a programming language. It's a framework which provides you a bunch of APIs. And what type of framework it is? It's a distributed framework. Okay, so it has data structures as well as APIs, and all the data structures which Spark bring to you are distributed in nature because it's a distributed computing framework. And all the APIs, most of the APIs also work in distributed fashion. Okay, so what Spark is bringing to Scala or Python is the distributed computing capabilities. Okay, so in most of the cases, the difference between Scala data structures and Spark data structures such as RDD are distributed related stuff. So list is a linear collection. Okay, and RDD is a distributed collection. That's why RDD stands for resilient distributed dataset. Dataset is a synonym for collection, dataset. Okay, so don't try to memorize. You need to understand the logic behind that phrase. I will talk about resilient at a later point in time. For now, even if you do not remember what is R, it is fine. But DD are important. DD stands for distributed dataset, which means distributed collection. Even as part of our collections, we have list, set, and map. Set is a collection, right? In this case, they are calling it as dataset. Dataset means collection. It's a synonym for collection, and other D stands for distributed. So the difference between list and RDD is distributed. All the APIs. So now let us see the list of APIs. So I have list L dot and hit tab. You see bunch of APIs. You have map, you have filter, you have reduce, so on and so forth. There are a bunch of APIs for you. Similarly, if I say order items dot and hit tab, there are not as many APIs as in list. There are, but still there are a handful of them. And if you look at some of the APIs, you have with the same name: map, filter, reduce, etc. Okay, so there might be APIs with same name, but depending upon the implementation of those names, it might behave significantly differently. So in list also you can use map, in reduce also you can use map, sorry, in RDD also you can use map, but the way it executes internally is significantly different, and we will see that at a later point in time. But from the syntax perspective, let me see if there are any questions from the chat. Yeah. From the syntax perspective, if I say l.map, you can see that it takes a function as argument. And how many arguments that function take? Map takes one argument, and it is of type function. Now I am talking about the function itself, which we need to pass to map. How many arguments that function take? So I have to pass a argument to my map function. Okay, and how many and that is of type function. One. It takes one argument. And what is the type of the argument here? What is the argument type of that function? So in this case, this is integer, right? And from where it got the integer? Why it is integer here? What is that? From the list is of type integers. That's why this function is also expecting an argument of type integer. And then what is B stands for here? What is B stands for? It says that. Why they are saying that is because what we typically do in map. What is the purpose of API map? Anyone from online? What is the purpose of API map? Map does. I'm not talking about hash map. I'm not talking about data structure map. I'm talking about function map. What is the purpose of map? Typically, when you should use map? No, that is different. You are mixing up the things. You are partially correct. It is primarily for the transformations. It's row level transformation. So for each row, if you want to transform the record of the row into something else, then we use map. As we are not sure about our return type. So depending upon your logic, you might want to return a tuple for each record. You might want to return an integer. You might want to return a string. It can be anything. As they are not sure what you will be returning, they are saying that here. So B represents that. Okay. If it is filtered, then it's Boolean, because you have to pass the logic which returns true or false. If it is true, it will consider that corresponding record. Otherwise, it will discard. So map is primarily for, what is the purpose of map, Vamshi? Row level transformations. Okay. So now you can write the logic to take each integer at a time and process it. If it is order items, and what is the type of order items? It is RDD, but still you have map function. And if you look at the syntax, it is actually same. The syntax is same. Even the map on RDD takes a function as argument, and that function expects an argument of type string, because our RDD is of type string, and it returns some unknown. Here they say u because it's unknown at the time of defining the logic for the map by them. Now, as per the logic we passed to it, it returns some type. Okay, that's why they say u. U stands for unknown here. Okay, don't worry too much about this. And then if I say l.map, It takes one argument, which is of type function. And what is the return type of that map? What is the return type of map in this case? What is the return type of map? Huh? What is the return type of map? I'm not asking about the return type of the function which we need to pass as argument. Yeah. So instead of list, you should actually read this. Okay. So always when you look at the syntax, it will give the return type. So scalar.collection.traversable ones, which is nothing but a collection. So answer is collection. Similarly, if we look at a map on order items, what is the return type for this map function on RDD? Now tell me what is the return type for the map function on order items. What is that? No, that is not the return type. It's that is part of this. So map actually take one more implicit argument. Okay, so that is the additional argument which it is taking. You don't need to worry too much about it. The return type is after this column. So this is the function specification where we have defined the function name and the arguments. The arguments end with that, and then column, and then the return type. So the return type is arg.apache.spark.rdd. So what map returns? Again, it returns an RDD. So you pass a RDD to map, it returns a new RDD. Instead of string, as it was earlier, now the return type will contain whatever you return. Whatever you return in each iteration as part of your logic, those will be the elements as part of this RDD. Okay. So now I can say val order items map equal to order items dot. Let's say I want to develop the logic for revenue for each order ID. Our data contains 6 fields. The second field is order ID, and the fifth field is order item subtotal. So I need to extract those two elements from each string. Okay. So here I can say OI implies. Now OI is of type. What is the data type of OI? What is the data type of OI? What is that? Be confident. Yeah, it is of type string. Okay. So using your string manipulation APIs such as split, substring, etc., depending upon the requirement, you have to now write the logic. So I have to return tuples, so that's why I put in circular bracket. So tuples are represented in circular brackets. Okay, and then I can say y dot split, comma, one will give order ID, and what shall we do now? To int to typecast to its original type. Similarly, we have to get the fifth field, and then we have to say true float. Now, what is the type of order items map? RDD, and each element in RDD is of type. What is the type of each element in this RDD, in this new RDD? What is the type of each element in this RDD? You have to integer and float. You have to use more appropriate term. You are correct, but what is that? What is that? What is that is called? If you put something in circular brackets, what is that? Yeah. So it is of type tuple. Each element in the RDD now is of type tuple. Okay, it's very, very important for you guys to use appropriate terms. Okay, the reason why I'm asking all these questions are so that you understand the logic, you memorize, and all those things. Okay, so now I want to preview the data from both order items as well as order items map. if it is collection, like L is in a collection in this case, and if I want to get first 4 records, which is the API I should use to get only the first 4 records or first 2 records in this? Head of 4, is there head in this? Yeah, there is a head. So head of 4. No, it doesn't take any parameters. So your guess is not correct. Let us see what head will do. Head will only fetch the first record. So 7 is correct. What is that, Vamshi? Collector. Okay, let us see. Okay, collect doesn't take argument which tell how many records it should fetch. So take is the answer. 7 is correct. You can say take and you can fetch the data. It will only take as many records as you pass to it, and it will fetch the data. Similarly, order items, which is of type RDD, also have an API called take. But to preview the data, you should always use take and get as many records as you want, and you can display on the screen. So once you say take of, let's say 10, it will convert. Now, what is the return type after applying take? What is the return type after applying take? So let me create a variable here, val t equal to order items dot take of 10. What is the data type of t here? Array of string. So when you say take, what happens? It not only fetch those many records from the RDD, but also it converts it into an array. Array is it a Scala API or a Scala collection or a Spark collection? Scala collection. Almost all Spark related data types will have arg.apache.spark. Looking that, you can say whether it is a Scalar data structure or a Spark data structure. If it is not from arg.apache.spark, if it doesn't have that, then it's not Spark data structure. So in this case, it is creating a Scala array. And then to print elements from an array, you can use for each and then println. And you can see the data in a more readable format. Similarly, I can say order items map dot take of 10 dot for each println. Now you got the tuples. Okay. Now, if I want to, if it is a collection, if it is a typical Scala collection, if I want to group by this order ID, and if I want to add these elements, what we have done earlier, we used group by. What group by does? It converts those 3 records into something like this: 2 comma, and again we'll have tuples, and then you will have values such as 2 comma 199.99, 250.0, and 129.99, right? Like this, you have the data, and then again you have to process this collection using map, extract this information, and you have to add those things. That's what we have done when we develop the logic with pure Scala APIs. Okay, but in Spark, there is an API called reduce by key. Okay, as long as your data is paired RDD. Paired RDD means each element in RDD has to be a tuple and it has to have exactly 2 elements. Those are called as paired RDDs. It's just a term we use. So in this case, order items map also can be called as paired RDD. Okay, as long as you have data in the form of paired RDD, you can use an API called reduce by key, and it will actually take care of grouping elements like this. Okay, it will automatically take care of grouping elements like this. But reduce by key also takes a function as argument, and that function should be whatever logic you want to apply on these elements. Okay, so reduce by key takes a function as argument, and that function you have to pass a logic whatever you want to do that do on those elements. If I want to get sum of each order, means revenue for each order, I just have to add these elements. Okay, and when we pass the logic, we don't need to iterate through the elements and create a global variable and all those things. The same way we have done with reduce, we can do it by using reduce by key, grouping by each element, and all the complexity will be taken care by Spark itself. Typically, if you have to develop the logic for a collection like this using conventional programming language, what you have to do, you have to group all the data within each key, and then you have to add. So whatever logic we have developed, right? We have created a global collection, which is of type hash map or dict if it is Python. And then within the for loop, while iterating through the elements, we have checked whether the key exists or not. If the key doesn't exist, we added the element to it. If the key exists, we add the incoming value to the existing one. And finally, we return a map to get a revenue for each order if you develop using iterative approach. Okay, so in this case, you don't need to worry about all those things. You just have to pass the functionality, what you want to do, what you want to perform on these elements. If it is total, I just have to say add those two arguments which will be passing to reduce by key. If it is min, we have to write min logic. If it is maximum, we have to write maximum logic, etc. So now let me leave it like this, and let me create order revenue equal to order items map dot reduce by key. And you can see reduce by key takes a function as argument. It takes function as argument, and that function, how many arguments that function take? 2, and both of them are type float, and the return type also have to be float. So we just have to add those two the way we have done with reduce, and then we the rest of the stuff is taken care for you. Here the arguments are not of type tuples, they are float. Okay, so within each key internally, it will not only convert data like this, but also apply the logic whatever is we are going to pass as part of the reduce by key. Okay, so here I just have to say total comma value, and then total plus value. Okay, so in each iteration we are just adding those two elements and resetting the total and moving forward until all the elements are saturated, and hit enter. Now what is the return type of this order revenue? RDD. And what is the type of each element in that RDD? Tuple. Okay, so now we can preview the data. Order revenue dot takeoff 10 for each println, and you see the data. We see first 10 records, but the order changes significantly. You will understand why at a later point in time. Don't worry too much. Okay, now I can save it into a file, or I can print like this, whatever you want to do. So to save into to save an RDD into a file, out of the box there is an API called save as text file. Using that save as text file, we can save it into the file. So now you compare with the Scala approach. It is very simple, and also it gives a lot more power to process huge volumes of data because it executes in distributed fashion. Okay, so that is the purpose of Spark and a brief overview about how you develop using REPL. Now, if you want to develop using IDEs such as IntelliJ, first you have to, once you create the project, go to the build.sbt, define the dependency, depending upon the version which you want to use as part of your production cluster. And then you have to go through the steps of creating the configuration object and context object, primarily the context object. Because in this case, the context object is internally or implicitly created by Spark shell. Okay, but when you actually develop an application, it will not be the case. You have to define or you have to create the Spark context programmatically. And I will cover at a later point in time. Don't worry too much about it. Okay. So this is brief overview about how you use Spark-based APIs to process your data. And whatever APIs we see here, like map, reduce, filter, are all categorized under core APIs. Okay, it's a Spark core module, and it has APIs like Scala map reduce APIs. There are hardly 80 APIs, and out of them, hardly 20 are important. And if you know those 20 APIs, you are good to go. You are at least at an intermediate level with respect to Spark. Okay, so that being said, we also when we actually talk about Python, we have spoken about data frames. Okay, what is the difference between data frame and a collections like list, set, and map? Can anyone tell what is the difference between the data frame which we have created with Pandas and a typical collection? What is the major difference? So the question is, what is the difference between data frames which we have seen in Pandas and the typical collections like list or set? Any guesses? Or yeah. So if more fundamentally, data frame have a structure. What is that? Huh? From where you got the metrics? That is not the correct. The more appropriate answer is data frame have structure. Okay. What does I mean by saying it it has structure? So data frame is nothing but a collection which have structure. What is the meaning of it? You are seeing the chat and you are giving the answer. Okay, let me close the chat. Now tell me. That is not correct completely. What is the meaning of having a structure to a collection? What is that? No. No. So when I say there is a structure, there are names to your columns. So you have list or RDD in this case. Order items or order items, map or order revenue. In each of these things, there is no name for each element. There is a data type associated with it, but no name for any of these things, right? So if I want to extract order item, order ID, I just have to pass the string, get the second element. That's it. There is no other way of doing it. You need to identify the position of the element. If it is a tuple, and you have to read that element. You can only read data using positional notation or by passing and by using positional notation. Okay. If you have a structure, you can also read the data with names of the columns. Okay. And that's the difference between a typical collection and a data frame. What is that? With attributes, yeah. Attributes are column names, whatever it is. So structure is nothing but the attributes have names. Okay. So now with Spark, whether you use Scala or Python or as a programming language, Spark itself brings a something called data frame and APIs on top of data frames to process the data, similar to Pandas data frames. Actually, Spark copied from Pandas, but it is much more simple and easier to use compared to Pandas. Okay, so for data frame there are multiple APIs. If it is Python, there is Pandas, but within Scala itself there is no data frames module. But Spark data frames work both in Python as well as Scala, also in Java. Okay. Now, for demonstrating on data frames, for what I can do is, if you are getting comma separated data like this. Okay, so order items is actually comma separated data that you can see here. Order items dot take of 10 for each println. Now you might want to create a structure for this data. There are multiple ways to do that. One way is by applying the map and extract all these elements into tuples, all these elements as part of a tuple, and then use an API called 2df and create a data frame out of it. So let me show you. So val order items df equal to order items, which is of type RDD dot map. Okay, y implies, I'm writing in multiple lines. First, I am creating a variable called a y dot split. Okay, so it will here. What is the type of a? What is that? Array of strings. So when you apply split on string, it will create an array of string. Okay. So the reason why I am doing this is, if I do not do this, I have to say y dot split of 0, y dot split of 1, y dot split of 2. I have to invoke that split several times, and it's unnecessarily typing extra characters. Okay. And also from performance perspective, also you are doing more operations than splitting once and then extracting the information from that splitted array. So here I have to create a tuple first to return as part of the map, and then once the map is done, then we have to apply an API called 2df to convert into a data frame. So here a of 0, which is of type int, so I'm using 2int. A of 1 again is of type int. A of 2 again is of type int. A of 3 again is of type int. A of 4, it is of type float. A of 5, again it is of type float. Okay. Now I'm closing this curly bracket and circular bracket. So if I do not use any other API, it will just create RDD, and each element in that RDD is of type tuple, and that tuple has 6 elements. Okay. To create data frame out of this, dot 2df. We just have to use 2df. If you just say 2df, it will give system names such as underscore c0, underscore c1. So it will create a structure for your tuple, but the names will be like underscore c0, underscore c1, underscore c2, etc. Sorry, underscore 1, underscore 2, etc. Okay, to give more meaningful names, what you have to do is you can pass the names comma separated to 2df function. So in this case, let's say the first one is order item ID, second one is order item order ID, third one is order item product ID, order item quantity, order item subtotal, and then order item product price. Now you got the names to those fields. Okay. Now I can say order items df.print schema to get the column names and data types. If I want to preview the data, I just have to say show. I don't need to say take for each println. Just say show. It will get first 20 records. If you want to get 100, you can say show of 100. Okay. And also, if you now say order items df dot and hit tab, there are more APIs than RDD, and one of the API is group by. Okay, and another important API is select. So if I want to just select two fields, I can say order item, order ID, and order item subtotal like this, and then show. You got only order item, order ID, and order item subtotal. So now you can actually access the elements with the names, which will give you a lot more flexibility to process the data further. Now to solve the same problem, which is to get revenue for each order, first what we have to do, we have to use group by. And once you create a data frame after grouping by, it exposes you more APIs such as sum, etc. And you can pass the field on which you want to add the add for each key. Okay. So in this case, order item df is of type data frame, not RDD. Okay. So now, and one more thing which you need to understand is we are using Spark 2.3.0, the latest version of Spark. If you connect to the lab and if you try to run this code, it might not work because the default Spark you will be launching is 1.6.2 on lab. Okay. I will explain those things when we actually get into Spark in detail. But in our local installation, we have 2.3 and all these things will work without any issues. Now to get the solution for the same problem statement, I can say order items df dot group by. Okay. And I can specify the column name. Our column name on which I want to group by is order item order ID. And now if I say dot and hit tab, it exposes these APIs. Only these APIs can be invoked after doing group by. And to get revenue for each order item order ID, we have to add order item subtotals. So I can say sum of order item subtotal and then show. That's it. That one line of code will take care of getting grouping the data by order ID and get the revenue. Okay, so this is solving the same problem with data frames API. Okay, so data frames give you a lot more flexibility because, and also your code will be much more readable and simple because you have names associated with it. And also internally, Spark adds some key performance features, which I'll be covering at a later point in time. For now, from the coding perspective, if you are familiar with data frames, it will be much more simple and also code will be much more readable. Okay. Yeah, by default it throws only 20 records. That's what. Instead of saying take off, you can say show. If you say take, again you have to say for each println. With show, it is automatically taken care for you. Okay, something is wrong. Okay. I think resources are saturated or something. I know why it is failing. The reason is by default it takes 200 threads to process the data when you use data frame operations. So there is a quick fix for that. I will show you in a moment. So the fix is, you can say spark dot conf dot set spark dot SQL dot shuffle dot partitions. I will explain why we have to do this at a later point in time. For now, just remember that you have to take care of this so that whenever you perform data frame operations, it works a bit faster. Still, it is not. I don't know why, but it is not picking up. Okay, probably I need to allocate more resources to this, or the session might be killed. So let me quit. Yeah, session is killed. Now let me launch this once again. History. Just give me a moment. So let us see if it works this time. Yeah, for some reason it failed earlier. Now it is working fine. Okay. So same thing. You can also, so once you have data frame, with the pandas, I also shown how to create a, how to invoke a query on the data frame. So in Spark also, it provides you the flexibility that once a data frame is created, you can run queries against it, or you can perform data processing using APIs like group by sum, etc. So in this case, to run queries, you can actually take this order items df dot. There is a API called create temp view, and you can give the name order items. Now a in-memory table is created. Now you can write select queries also on top of this. So for this problem statement, the select query will be like this: select order item, order ID, sum of order item, subtotal, from order items. Then what we should do? I need to get revenue for each order ID. What is that? Huh? So it's like restarting Windows laptop. If for anything not working, just restart. So if you don't know the answer, for each println. So still the query is not complete. You have to say group by. That's why you have to practice order item, order ID. Okay. So this is the query we can run to get revenue for each order ID. And this is the simplest of query. If you fail to get an idea that you should write this query, it is very, very tough for you to code, and also it is very, very tough to clear any technical interviews. Okay, so make sure you are very comfortable with SQL. You have to practice, you have to run the queries I have shown. You need to understand the problem statement and you have to come up with the response. Okay, so in this case, I can pass this. So if you have to run a query, once the table is created, using Spark session object, which is Spark, there is a API called SQL, and then you just copy paste that query. And then Spark.SQL always returns a data frame. To see the results from the data frame, you can say show, and you can see the results. Okay. You can also use a function called round. What does round do? What is that? Iterator. Yeah, you can set the limit on your decimals. Now it is a bit more readable. Okay. You can also give the alias to the column name, alias to this derived column using as clause, and it will be a bit more readable. Okay. So this is how you can actually process the data using Spark SQL on top of data frame. Okay, and these are the things which you should be focused on when you get into Spark. You should have a good understanding about core APIs, but you need to have a expert level knowledge when it comes to operating data using data frame operations. As Spark is evolving into more towards data frames in future. Okay, and to get comfortable with data frames, you have to be comfortable with SQL. If you are not comfortable with SQL, you will not be able to comfortable with data frame operations. Is it clear? So make sure you go back to the database essentials by Monday and practice all the queries which I have demonstrated on Oracle. And then we will actually come back and learn a bit more or refresh and do more examples using Spark SQL and also using data frame operations. So focus on data frame operations practice along with Spark SQL and be comfortable with both the data frame operations as well as Spark SQL. Okay. So don't worry too much about that. We will talk about later. It is internally performing some type conversions because we are using round. Okay. So that being said, this is brief overview about how you can develop the logic using Scalar as a programming language and Spark APIs. We have explored core Spark. We have explored data frames and operations on top of data frames. And we have explored Spark SQL on top of data frames. Okay. So same thing we can do with Python also. And to get into Python, you just have to use PySpark and launch Python-based REPL along with Spark binaries. It also creates Spark context and Spark session objects. Okay. So earlier, when I run SQL, I use Spark.SQL. What is Spark? Again, it's an object which is created when the Spark shell is launched. You can see it here. Even with PySpark, it will also create Spark on top of SC. Okay, you can say SC and you can get the data type of SC, and you can say Spark and you can get the data type of Spark. Okay, now I will quickly write the code using Python. Okay, now I am saying order items. It will take another 5-10 minutes and we'll wrap up for today. So Kamlesh is asking clients and file write a request from gateway node to RM. So don't get into all those things for now. I just want to show you how to get started with Spark programmatically. Related to all these things, we will see at a later point in time. Okay. I haven't covered the internals about how the code will be executed and all. Those will be covered at a later point in time once you have some level of understanding about APIs. Okay. So in this case, order items equal to sc dot text file users itversity research data retail db order underscore items. Okay, as it is Python, we don't need to say val or var. You just give the variable name, and then you can say order items dot map. Okay, and y implies y dot split comma of 1. It is of type integer. The way you can typecast is by using function like this, not using dot to int. Okay, float y dot split what is that? Okay, and then okay. So in this case, it's Python. So I have to use lambda function, lambda keyword. Just a syntax difference. And then if I want to break the code into multiple lines in Python, I have to use this backward slash. I can say reduce by key lambda total comma value total plus value. Okay. Now if you want to see the output, you can say dot take off 10. Now you see the revenue for each order ID. Okay, if you want to print, you just have to say for in, because Python doesn't have for each type of API. That's why you have to say for in, and then you can use this logic, and then colon, and then within the scope by using indentation, you can say print I, and it will print the results one by one at a time. Okay. Now, if you want to create a data frame out of it, all you need to do is order items dot map, and as part of the map, you have to write the logic which creates the tuple, and you have to invoke 2df function. But the way you have you give the names using 2df in Python or PySpark is a bit different, and we'll get into those details when we talk about Spark in detail. Okay. For now, just to create a data frame and show how to process data on a data frame, I'll be using JSON data. With JSON, already you have field names and the values in it. Let me show you. Now I am going to retail DB JSON, and if I go to order items, there is this file, and if you look at the data, it is JSON. So this is one record. There is a field name and a value, field name and value, so on and so forth. As there is a structure already, Spark actually provide APIs to read this structured data into a data frame directly. And those APIs are available under Spark. Under Spark, there is read, and then read have JSON. And here you can pass the path. What is the path? In this case, I just have to say underscore JSON order items. Okay. Now, order items DS is a data frame which is created out of your JSON data. So on top of SC, with APIs such as text file, the Spark session object called Spark also have certain APIs to read structured data. It has APIs like JSON, Parkway, ORC, etc. We will get into those details when we get into Spark in detail. Okay, but for now we created a data frame. You can say order items df.show Here, circle brackets are mandatory in Python. Okay, and you can see the data. Now I can say order items df dot group by order item order id dot sum of order item subtotal dot show. Again, I have to put in the circle brackets. How you see the data. Okay. Similarly, I can also say order items df dot create temp view and then say order items. Okay. And then use spark.sql to run the query, which I have ran earlier. The same thing will work, except the show, we have to put show circle brackets and it will run the query and it will get the results. Okay, so it's almost same. That's why I am covering both Scala and Python, even though it sounds too much for you in the beginning. Syntax is almost same. If you learn with one programming language, and if I dump you onto some other project which uses Python instead of Scala, at least you should be able to read through the code and you should be able to understand it. You might struggle a bit to fix or to make any modifications because you might not be aware of syntax and all, but at least you should be able to understand the code and you should be able to start working on it from day one. That's why it's better to learn both the programming languages to be a data engineer, especially using Spark as the framework. Okay. So you see the similarities, whether you use Scala or Python. As we are using Spark APIs, the code is very, very similar. Now let me take few questions. Okay. Kamlesh is asking, client send file, write request from gateway node to resource manager, and RM get file system information. I think you are mixing up things, Kamlesh. So someone is annotating. Let me disable attendee annotation and also let me clear. Okay. So client doesn't send request. So you are mixing up the things. From gateway node, if you just want to write files using, I'm connecting to the lab now. So on gateway node, either you can run MapReduce jobs using Hadoop jar, or you can use Hadoop FS and say -put and copy files. So if you say Hadoop FS -put to copy the files, then the client directly go to name node. There is no resource manager involved in it. Okay. So if client send file write request from gateway node, it doesn't go to the resource manager. It directly go to the name node, and then client will get the information about the HDFS load on the cluster from the name node, and the client will work with data nodes directly to copy the file. So there is no role for resource manager if you use command like Hadoop FS -put or -copy from local. It is purely HDFS task, and there is no MapReduce involved or Spark involved in it. Okay. Is it clear, or do you have any other question? Hello, Kamlesh. So when the client send file write request from gateway node, it directly go to the name node, and it will get the information about the load, HDFS load on the cluster, and then it will work with data nodes directly to copy the data. So there is no yarn in that context. I'm not sure whether he is on or not. He is not responding. Yeah, go ahead. Yeah. That's what it's a file system activity. There is no resource manager involved in it at all. So if you use Hadoop fs-put to copy the files, it doesn't involve resource manager at all. Even without yarn, you can, even without yarn, even without setting up yarn at all, you can run this command, Hadoop fs-put to copy the files. When you run the jobs, so yarn is processing framework. When you have to process the data, then resource manager comes into picture, or yarn comes into picture. If you don't want to just, if you don't want to process the data, if you just want to load files and keep it for some compliance reasons, you don't need to even set up yarn. That's what this statement is completely irrelevant for processing. You said that client send file write request from gateway node. So client doesn't use resource manager to send write request. Okay, he just issue commands like this Hadoop fs-put or some direct APIs, which is part of HDFS, and he will try to write. So if the requirement is to just to write files into HDFS, then resource manager doesn't come into picture at all. You have to rephrase your question, and I will be able to respond. So the rest of this stuff is completely relevant to copying the file. There is nothing related to resource manager. So you have to rephrase the question, and I will be able to respond. Okay. So I will take that question tomorrow after tomorrow's class. So you can rephrase the question, and I will be able to clarify. Okay then. Yeah. Thank you. We will catch up tomorrow. Bye.